And then the second thing that needs to happen is we also have what are called corresponding sides. Those aren't going to be congruent. Otherwise, you'd have the exact same shape. All right, all corresponding sides have the same ratio. So we're using words like ratio, scale factors, that sort of a thing, before we left for a little mini break there. All right. So just kind of refamiliarize ourselves with that. That's what these first four are getting into. So it says decide whether the following polygons are similar. If so, you're going to write a similarity statement. Okay, so you remember how we kind of wrote those, and then give the similarity ratio. So kind of a lot of stuff here in once is a little review. So letter A. If we kind of go point by point here, all these corresponding angles need to be congruent. So when we look at it, if we look at letter A, we know these are all 90-degree angles, right? They all have these little squares in them. These are definitely all going to be 90. So the only way these can be congruent is if I can look over here and know for a fact that these are also all 90-degree angles, okay? However, when we look at this, the arcs, the number of arcs tell us that these two guys are congruent because they all have single arcs. If we look at these with double arcs, they're telling us that these two are congruent. But since they are marked differently, that would indicate they are not congruent to each other. All right. So if these are all congruent and these two guys are congruent, the only way these could all be congruent is if they're all 90 degrees. Is there any chance that these four angles are all 90 degrees? No, they're different. Like these two blue ones are the same. These two yellow ones are the same. So in this case, when we try to identify if all those angles are congruent, all right, they are not. So when it says decide whether they are not, you would basically say, no, I'm not asking you to justify it, but if I did, it was just because all those corresponding angles are not congruent. Okay. All right. Then what we did on Friday, or no, we quizzed Thursday, right? And then we didn't get them back to you. And then we started something new on Friday. We started talking about similar triangles. So similar triangles have a little bit different idea. Remember how we talked about three things: angle, angle, side, 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 and then side, angle, side. So if we are dealing with triangles, it makes this a little bit easier. We don't have to quite go through all of these steps and check for every single angle and then every single side. What we're really just concerned about is, do we have two angles, corresponding angles that we know are congruent? Do we have all the sides that have the same ratio? Do we have side, angle, side? So here we actually have some options in this. If I ask you, are we given two sets of corresponding angles that are congruent to each other? Could we say that we do have two sets of corresponding angles that are congruent? Yeah. All right. Here, this has a single arc. This has a single arc. So that checks off one of the corresponding angles being congruent. If we look at the double arcs, I have this angle congruent to that angle. So in terms of a quick little review, we could actually say those triangles are similar right now. So we could say a yes. And then because they are triangles, we really could just say because of the angle theorem. You just put because of AA. All right. Now, we don't really need to go any further, but as a quick little review, like side, side, side would be just looking at all of those sides. So if I compared like sides, like the 12 and the 9, if I divided those, 12 ninths reduces down to be 4/3. Well, if I look at the corresponding sides between the blue and the yellow, 8 and 6, doesn't 8, 6 also reduce down to be 4/3? And then if we did the 6 and the 4.5, not quite as obvious, but 1.5 would go into those 4/3 times as well. So we also have side, side, side. So there's some different options here, but this is kind of what we left off doing when we're dealing specifically with triangles. So you're going to say yes because of the angle theorem. We then want to write a similarity statement. So my statement, I'm going to start with the single tick mark, then I'm going to go to the double, and then I'm going to go to the unmarked one. So I'm going to say triangle LMN is similar to, so then you use a little squiggly is how we were identifying something is similar. And then on the other side, we have to go in the same order. So since I went from the single arc to the double arc to the no arc, I have to do that here. The single arc is T, the double arc is P, and then the one that is unmarked is O. All right, and then we have all those corresponding angles in the correct position in those statements. And then we want to give the similarity ratio. That's what I was doing up here. So 12 to 3 reduces to be 4/3. This reduces to 4/3. So our similarity ratio is 4 to 3. And I didn't necessarily say from one to the other. So at 4/3 would be fine to write down. Okay. All right. C. Not triangles. So now, since they're not triangles, now we do need to be a little more thorough. We need to make sure that all corresponding angles are congruent. Are all corresponding angles going to be congruent here? Yeah, because they're all 90 degrees in both shapes. So we've kind of checked off this first idea up here. This corresponding angles being congruent. Now all the corresponding sides need to have the same ratio. So we'll go left side first. So I'm going to take this left side. I'm going to compare it to that left-hand side. And that ratio would be 10 to 8, which if we reduce down is 5/4. Then we'll do the top side, compare it to the top side. So that ratio would be 6 compared to 4. Will 6 compared to 4 reduce down to be this 5/4? No, that's going to be reducing down to be 3/2. So right away, are these two guys the same ratio for those two figures? No. So this would be a no, and then we don't have to worry about all the other stuff that I asked you to do. Okay. All right. Letter D, again, it is a two triangles. So we don't have to worry about every single angle and every single side. If we can identify any of these three ideas here and confirm that two sets of corresponding angles are congruent or all the sides have the same ratio, then we can do this a little bit quicker. So when we look at this, for sure, these are congruent. Those 90-degree angles are congruent. So we have at least one angle if we want to focus in on the angles. And then don't we also now get told that these angles are also congruent? So because of that, we can right away, without even really worrying too much about checking the sides, say that, yeah, these guys are going to be similar. Go ahead and do your similarity ratio, because there could be a lot of different routes you could take with writing this. One isn't better than the other. So you write your ratio, your statement, your similarity statement. So you're going to say triangle what is similar to however you're going to name that second triangle. All right, Jada, how'd you name your first triangle right here? XAR. So she went XAR. So she went from the one that's not marked to the 90-degree angle to the single arc. So that means over here you're going to write what, Jada? Good. MNT. Unmarked to the 90-degree angle to that single arc. So as long as your X and M are in the same position, you're good. So if yours looks different, as long as they're in the same spot, as long as A and N are in the same position, R and T, then your statement should also be correct. Okay. Now the ratio I do want. So now we are going to look at our sides real quick. 9 compared to a 6 is 3/2. That should be all of them. If we're saying that they are similar, that's really all we would need is just figure out one. But we can confirm that if I did 15 over 10, doesn't 15 over 10 also reduce down to be 3/2? And then 12 to 8, reduce that. That's also a 3/2. So 3/2 is our similarity ratio. Okay. Yeah. Oh yeah. I was thinking we quizzed on Friday. We just didn't give it back, did we?
Yeah.
Yeah, I'll get it at the end.
Okay.
Yeah. Thanks for the reminder there.
Jake reminded me.
Okay, cool.
I completely forgot.
I was thinking we quizzed on Friday also because I didn't give them back.
Yeah, because either of us.
Yeah.
Graded.
Yeah. All right. Yeah, we'll get that assignment in a little bit here. Okay, go to the back page. All right, example 2. It says, in the diagram at the right, the parallelogram RSTU is similar to the parallelogram LMNU. All right, so real quick, this is what we quizzed on. You're going to get those quizzes back here in a minute. Overall, we understood kind of the ratio, and if I'm going to go from this one to this one. But a quick little review here. See if we can do A and B, because this kind of gets at the heart of what we just quizzed on. This one is saying I want the scale factor of this to this, but then in the very next one, I'm going to have you reverse it. So just to make sure we kind of understand which fraction we want, because then obviously the other one's going to be the reciprocal, right? Okay, then as you're doing it, because it's not a ton of work, here's kind of an unofficial little check. If I'm going to go in letter A from RSTU to this one, if I went from this shape to this shape, what did we do? Get bigger or smaller? Smaller. So check your answer real quick. If we got smaller, your ratio better be less than 1. All right. So if you have one that's bigger than 1, you probably have the next answer. Okay. You probably have the answer to letter B. All right. So if I want that ratio to be less than 1, what do we think? Anybody now confident in their answer if it was less than 1 here? Ella? Good. Should be 2/3. Okay. Again, you can just kind of memorize. It's always what you're going to divided by where you're coming from. We are going, if I could look at the sides that we knew, these are the two sides we knew. We were going to the length of 2 from the length of 3. That then gives us that ratio that's less than 1. And then all I ask you to do in B is now go the other direction. So go from the smaller one to the bigger one. So for understanding that, now we better be greater than 1. It's really just the reciprocal of the one that we just did. So that would be your 3/2. Okay. All right, C. Also, these are on our quiz. Find NO. See if you remember what we were doing all last week to find the length of NO. So, all right, so this is the guy we want. So we'll call that our X. Figure out what length that has. All right. Slightly a little bit sneaky, but you're all pretty bright. I think you'll understand this. So this is the side we want, is the bottom side. So we want to compare it to the bottom side right here. Did I give you the length of that bottom side? No, but if this is a parallelogram, what do we know that length has to be? Yeah, it's got to be the same as the 6 that's above it. Okay. So we have the 6 now, that corresponds to the X, and then the sides that we know is A3 over A2. So this is when we set up our proportion. There's a couple different routes you could take. Let's say I went 6 over X. So if I do it that way, I'm going the bigger one on top and the smaller one on the bottom. So if I choose that option, the 6 over the X, then when I set up my proportion, I better keep the bigger side over the smaller side. So the other sides that we know are the right-hand sides of each. The big right-hand side would have been 3. The smaller right-hand side is going to be A2. If you flip them, so if you did more, you could also do X over 6 equals 2 over 3, because then I did small over large, they're going to yield the exact same solution. Okay. But that's when we set up our proportion, and then we crisscross once they were set up. We understood that pretty well. That's pretty easy. And then divide, so that X should be A4, and then X was the length of that side. All right. All right, D, find the measure of angle U. since these are similar, it satisfies the idea that all corresponding angles are congruent. So if I know that this is 125, that tells me that this here is also 125. So angle T up here has to be 125 also. All right, corresponding angles are congruent. Within a parallelogram, one of the things we talked about, opposite sides are congruent. So that means, or opposite angles are congruent. So that's 125. This is 125. The angle we're ultimately looking for, though, is this guy right here. Okay. So the way we talked about this, since we don't know like its corresponding angle down here, we don't know any of these opposite angles, is these are what we call consecutive angles. They're right next to each other. So these are consecutive or these are consecutive. And consecutive angles are what? Yeah, 180. They are supplementary. So if I have 125, then to get this angle right here, I just want to take the 180, the idea of supplementary, subtract away the 125 that we have with that consecutive angle. That has to be a 55-degree angle. All right, bringing back some really old stuff from our properties of parallelograms. Okay. Then the only thing that is somewhat new today, letter E, find the perimeter of each. That's not new. That's something you've been doing for many, many, many years. So find the perimeter of this smaller one down here, L, M, N, O. So write that down. All right, and Mo, what's our perimeter of this guy down here?
12.
Good. The perimeter should be 12. Perimeter is adding up the lengths around the shape. This was 4, so then this has to be 4. The right-hand side is 2. That means the left-hand side is 2. Add them all up, and our perimeter ends up being a 12. Okay? What I want you to then do in letter F, find the ratio of the perimeter of RSTU to the perimeter of LMNO. Well, we already know the perimeter of LMNO, right? That is a 12. So the missing piece of information for us right now is the perimeter of the bigger shape. So real quick, find the perimeter of the big one. All right, and Julia, what do you think for the perimeter of that one? Good. That should be 18. I have 6 here, 6 here. If this is 3, then this is 3. She just added all of those up. That has a perimeter of 18. All right. So old perimeter idea. We're just adding up all the sides. So now what I want you to do is find this little ratio of this one to the LM and O. So again, you can just think of the idea that whichever one we're going to is going to be your numerator, and whichever one we're coming from is going to be your denominator. So I am going to LM and O. So that's going to be 12. And I am coming from the larger shape of 18. Notice how that reduces. These will both be reduced by a 6. That reduces down to be 2/3. If we revisit A and B, when we went from RSTU to LMNO, so RSTU to LMNO, didn't we get the exact same ratio for their lengths? Okay, so that is not a coincidence. So whatever the scale factor is from one shape to the other, it will be the exact same answer for their perimeters. Okay, and that is something then that'll save us time. We don't have to do all the work all the time. We just know that's always going to be the case. All right. All right. So the last two then, or the last few, 3. A, do that one first. Find the scale factor. This one I'm not specific, so you can't mess this up. So I don't tell you which one we're going to go to and from. So either version should be okay. All right. We just have to be a little careful of with this one is this triangle, you're only given one side that we actually know. It's this guy right here. So making sure that we pick the correct side, because you're given 3 different sides over here, just making sure that we're going to take this 10 and compare it to the correct one, the corresponding one. There's 2 ways you can kind of think of it. That red side that I have highlighted goes between A and B. So whatever side goes between P and Q has to be the corresponding side. So that would have to be this one. Or if you understand right triangles, isn't this the hypotenuse? It's opposite of the 90-degree angle. So that means the hypotenuse here has to be the similar side or the corresponding side. So the 10 had to be compared to your 25. All right. I didn't tell you which one to go to and from. So you could either do, so let's do 10 over 25 reduces down to be 2/5. So if you got that, that's fine. Or 5/2. Just depends on which one we're going to and which one we're coming from. Okay, so either way, we would take either one. All right, B, find letter A. So now find this missing letter A down here. All right, letter B, where we're going to try to find letter A. Joe L, what'd you set up there?
15 over 8 times 25 over 10.
Okay, so he went, when he set his up, so yours might look different, and we've said this many times, that's okay. He did the big side, or the big triangle, over the smaller triangle. Okay, so totally fine. He said 15, so he took this here, and he put it over the X, which was its corresponding side. All right, so this guy corresponds to here. I guess that's A. And then he then used these 2 red sides that we knew, and he did the bigger over the smaller, so 25 over 10. All right. So again, you could have a little different version, but that should still work. So we crisscross and solve there. So 15 times 10 would be 150. The 25 times A, or X, if you use the X, 25A. What'd you ultimately get then, Joe?
6.
Good. Divide those over, and then your A should have been a 6. So we now know this is 6. Since that's what Joe picked, we'll go ahead and stick with that then. So now we just need the missing side that we don't have highlighted yet. I'll continue to do the big over the small. So 20 is the big side. It'll go over the small triangle's corresponding side, which is B. And I would just use that 25 and 10 again. All right, and then that's our proportion. Okay, so crisscross solve. So 200 is equal to 25B. Divide by 25, and that should be what? 8. Okay. All right, now D. We're going to do this the long way one more time. And then in the future, when you see this question, we could just go right to this answer. So it says find the ratio of the perimeters. So let's say we did the perimeter of this smaller triangle. So the small triangle, if we added all those up, we now know all the sides. 6 plus 8 is a 14, plus an extra 10, that's going to be 24. If we add up the sides of that big triangle, the PQR triangle, what do we get? 25 and 15 is 40. 40 plus 20 is 60. Write that down. I want the ratio of those. So you can pick either or. I'm not telling you in which order. So you can either do 24 over 60 or 60 over 40. It's up to you. I'll do 60 over 40 or over 24. No, a little harder to redo. Anybody know the largest number that goes in both of those? That makes everybody's life easy. Omar? Good. So we could actually divide each of these by a 12. 60 divided by 12 would be what, Omar? Good. And then 24 divided by 12 would be what? Good. Didn't that match? And again, I wasn't specific. Didn't that match one of the options for letter A? All right, the same with their sides. Okay. So the only real new thing, all this is like a little review after a little break. If you are ever given two figures that are similar, then the ratio of the perimeters is equal to the ratio of the sides. Okay. Or ultimately the scale factor, whatever that scale factor would be. All right. So that in the future, if you see letter D and we already did letter A, we don't really need to add them up. Or if I don't give you all the information, we would still know what that is very quickly. Okay. Okay. You did have homework over the weekend, as we learned. So I don't want to not give you credit for that because I'm sure many of you did it. So go ahead and pull that out. Is there anything we need to talk about with that? It's the whole angle, side, side stuff. Before I grab those. Yeah. Let me open it up. I didn't even have it open. I totally forgot about that. Actually, let's not do that. Recent 6.30 homework. No, that's not what I want either. Shoot.
Copy.
6.3. And I can't even find it. 6.3 notes. 6.3 notes. 6.3 homework. Can I see that real quick? I know where I have it. Which one, Jada? 8. Which one? I don't know where I have it. Shit.
It's gone.
I guess. I'll find it when I don't need it. All right, 11. So on that, make sure I read the directions. So what we're trying to do is find the value of x in each pair of these similar triangles. So this is 6, 9, x, 4, 6, 8. You certainly have to pick the bottoms for sure because this is our answer. So you definitely want to pick that x and compare it to its corresponding side, which is going to be the 8 right here. So we would do the x to the 8. And then it's really up to you which are the other two sides. I definitely went from this one to this one. So for me, I'll do the left-hand side and compare it to this left-hand side as 6 over a 4. And then we just crisscross and solve. All right. Okay. Any others? Good. Okay. Pass that in then. Make sure you got your points for doing that. All right, then you're going to get two things now. So this first one is just the word for the notes we just went over. So this will be due tomorrow. And then we'll give you your quizzes back. And if you'd like to do quiz corrections, those would also be due tomorrow. Omar. Hello. Jake. Yeah. And I'm still recording, I think.